Hello and welcome back to another video on data analysis. And in this video tutorial, we will understand data cleaning using Python Pandas. Data cleaning is a crucial step in the data analysis process as it helps to ensure that your data is accurate, consistent, and ready for analysis. Hello, I'm Madhuri Jha, DevOps Specialist at ThinkNix Technologies. I've compiled this content just for you. Before moving further in this video, we will cover the basics of data cleaning. Later, we will discuss the common data cleaning tasks, learn about the prerequisites necessary for the hands-on demo, and I will walk you through a hands-on demo to clean a sample CSV file. By the end of this session, you will have a good understanding of all the steps involved in data cleaning. Data cleaning is an important step in the data pre-processing phase that involves identifying and correcting errors, inconsistencies, and inaccuracies in your data. Before you can effectively analyze or model your data, it must be in a clean and usable format. Data cleaning ensures that your data is accurate, consistent, and reliable, leading to better insights and more accurate outcomes. Why is data cleaning important? Raw data often contains errors such as duplicates, incorrect values, or missing data. Cleaning the data improves its accuracy, which is essential for reliable analysis. Inconsistencies in data, such as different formats or inconsistent labeling, can lead to confusion and errors during analysis. Cleaning the data ensures uniformity across the dataset. Missing values can lead to biased results or errors in machine learning models. Data cleaning helps identify and address missing data to improve the completeness of the dataset. Clean data reduces the time and effort needed to prepare and analyze the data, making the entire data processing pipeline more efficient. Before we dive into the demo, let's go over the prerequisites. To follow along with this tutorial, you will need to have the following installed on your system. Make sure you have Python installed. You can download it from python.org. Pandas is a powerful data manipulation library in Python. You can install it using pip by running this command, pip install pandas. If you wish to know basics of pandas, that you can watch the video on data analysis of Python in our ThinkNix YouTube channel. The link will be provided in the description box of this video. Next is Jupyter Notebook. This is an interactive environment where we will write and run our Python code. If you don't have it installed, you can install it with pip install notebook. Once everything is installed, you can start Jupyter Notebook by typing Jupyter space notebook. This will open a new tab in your web browser where you can create and run your Python scripts. Now let's briefly talk about common data cleaning tasks. Data cleaning involves a variety of tasks such as loading the data, inspecting the data, filling in missing data or removing incomplete records, ensuring the data is in the correct format, example strings, numbers, dates, identifying and removing duplicate records to avoid skewed analysis, selecting only the relevant subset of data for analysis, and finally, save the clean data. After the concepts are clear, it's time to get our hands dirty to clean up data to make it useful for analyzing it. Let's move over to Jupyter Notebook where we will clean a sample CSV file step by step. Let's start by opening command line terminal and begin with installing Jupyter Notebook. Pip install notebook. It will take a while to install Jupyter Notebook. As you can see, the requirement is satisfied as it is already installed in my system. And after the completion of installation, run the notebook by typing Jupyter space notebook at the prompt. Check if pandas is installed. If the command throws error, install pandas first. Pip install pandas. Let's start by loading our dataset into a pandas data frame. I have a sample CSV file here called rawdata.csv. First, we will load it into pandas and take a quick look at the data. If you have no idea how to load files in pandas, we have already covered this in previous video on data analysis, and you can even go through our blog at ThinkNix portal. You can find the links in description box. Now that we have the data loaded, step 2, let's inspect it. We will check for missing values, incorrect data types, and any potential errors in the data. The first step is to look at the summary of the dataset. Print df.info. df.info function provides an overview of the dataset, including the number of entries, columns, data types, and memory usage. This helps in understanding the structure and contents of our data frame. Next is check for missing values. df.isNull.sum. It counts the number of missing values in each column, helping you identify columns that may need imputation or other handling to ensure data completeness. df.duplicated.sum function returns the number of duplicated rows in the dataset, allowing you to decide whether to remove duplicates to maintain data integrity. Moving further, as you can see, our dataset has few issues that need to be cleaned. Let's begin with handling missing values. We can either fill this missing values with a specific value, or we can drop the rows or columns containing them. If a row has more than half of its value missing, it's better to drop it. For other rows, we'll fill in missing values with the mean of the respective column. So let us drop the rows first using .dropNA function. df.dropNA thresh equal to len df.columns removes rows where more than half of the columns have missing values. The thresh parameter ensures that only rows with at least half of the columns filled are kept, helping to preserve rows with sufficient data for meaningful analysis. .replaceNA fills missing numeric values in age column with the column's mean. It first ensures that NA values are recognized as missing, converts the column to a numeric type, and then replaces any remaining NaN values with the mean of the age column, ensuring data completeness for further analysis. Let's repeat the same for another numeric column, salary. The following code handles missing values in the salary column by first converting any NA strings to actual missing values NaN, then ensuring the column is in numeric format. Finally, it fills the missing salary values with the column's mean, maintaining consistency in the dataset. As you can see, the age and salary have huge decimals, needs rounding off to 2 decimals for consistency. Next, we'll ensure that data types are correct. We'll convert the age column to numeric and correct the format of the date column. To do this, we have two functions in pandas library, to_numeric and to_datetime. So let's use them one by one. To_numeric, as discussed earlier, converts the age column to a numeric data type using errors equal to coerce to turn any non-numeric values into NaN. This ensures that the age column is consistently numeric, which is essential for calculations and analysis. When you use pd.toDateTime with errors equal to coerce, pandas try to parse all dates assuming a standard format, and entries that don't match this format are converted to NAT, not a time. This code checks for any dates that couldn't be converted by identifying rows where the date column is NAT. Now we'll check for and remove any duplicate rows that might skew our analysis. Drop_duplicates in place equal to true. This code removes duplicate rows from the data frame, ensuring that only unique records are retained. The in place equal to true argument updates the data frame directly. cleaning the data of any redundant entries. Now that we have cleaned the data set, we can filter it to focus on specific data that might be most relevant for our data analysis. For example, we might want to filter the data to include only employees from certain departments or perhaps only those with a salary above a certain threshold. Let's say we only want to look at employees from the engineering department. We can filter the data set accordingly. Alternatively, we could filter the dataset to include only employees with a salary greater than 60,000. Finally, after all the necessary cleaning steps, it's important to save the clean data for future analysis. This ensures that your hard work is preserved and ready for use in your next steps. At the end, check and load the clean CSV file to the data frame and view first 10 rows. Here it is. That concludes our demonstration on data cleaning. Now that we have successfully cleaned and saved our dataset, we can confidently move forward with our analysis, knowing that the data is accurate and consistent. Data cleaning might seem tedious, but it's a vital part of the process that can significantly impact the quality of your results. By taking the time to properly clean your data, you are setting the stage for insightful and meaningful analysis. Thank you for joining me in this tutorial. I hope you found it informative and engaging. If you have any questions or need further clarification, feel free to reach out. Happy coding and happy analyzing.